Okay, continuing along, problem number 6. It says, given circle O, which you remember circle O just is named by the center of the circle. Okay, it says the length of arc AB is 3.68. Okay, and they say that the measure of arc AEB is 260. And they're saying based on that we should be able to find find the radius of the circle. All right, so with this problem, I'm seeing that they're giving us the length of the arc. So I'm going to write down just the length of the arc formula. I'm not going to plug in anything. The length of an arc, okay, so I'm going to use arc length. I'll just write it out. Okay, arc length equals its angle, or I'll say arc measure, which is the measure of the arc, the number of degrees, over 360, okay, times pi d, okay? And this is our formula. So it looks like they gave me the length of the arc, and they said it was 3.68. So in this arc length position, I'm going to write 3.68. Okay. They didn't give us the length or the measure of arc AB. They didn't tell us how many degrees AB was. They told us what AEB was. It was 260. So if I kind of trace A to E to B, okay, they're actually telling me about this. Okay. The long way around the circle, what we call the major arc, okay? And I don't want to know about that because the length of the arc that they gave me was AB, and that's the direct way from A to B. It's the minor arc, okay? So you got to be careful, okay? We don't know what that is. We know that over here it's 260, and so what that's nice for us is that if this is 260, the minor arc is the rest of the 360, which means it has to be 100 degrees, right? So just be careful when they're naming arcs. If they put that extra letter inside, they're asking you to kind of go the long way around, right? We don't want that one. So we're going to say 100 out of 360 times pi d, okay? And so now we should be able to figure out what the radius is, okay? So I can, I'm going to do this in 2 steps just to make it a little easier. I'm going to multiply both sides by the reciprocal of 100 over 360. If you want to get rid of a fraction, which we really do, we really want to solve this problem for d, because if we know what d is, we can just cut that in half and find a radius, okay? So I'm going to multiply both sides by the reciprocal of 100 over 360. And the reason that I'm doing that is because if you have a 360 on the bottom of a multiplication problem and a 360 on the top of a multiplication problem, they cancel each other out. And that's what I want to happen. I want this to go away. Same thing happens here. I have 100 on the top and 100 on the bottom. They cancel each other out, right? Great. The right-hand side simpler than it used to be. That's what I was trying to do. But I just have to make sure that I also multiply the left-hand side by the same thing, 360 over 100. Okay, so let's simplify that. Okay, if I do, okay, let me grab my calculator so we can do some simplifying. Okay, if I do 3.68 times 360, get that answer, divide it by 100, I get about 13.248. I'm not going to round because this is the middle of a calculation. Okay, and that equals pi d, right? So now I'm trying to find out what d is, and this is pi being multiplied by the diameter. So I'm going to divide by pi on both sides. Okay, and so if I go to my calculator now and I do 13.248 and I divide it by pi, okay, and I'm using the pi button so it's completely unrounded, I get an answer of about 4.21. It says to the nearest tenth. Okay, so I'll say about 4.2. So the diameter of this circle is 4.2, which means the radius is half of that, which we can do that one in our heads, about 2.1 centimeters. Okay, so we have to actually use arc length, solve an equation by working our way backwards. Okay, problem number 7, find the area of the sector. Leave your answer in terms of pi. So the area of a sector formula, area equals still arc over 360, the measure of the arc, the number of degrees. But now I'm going to multiply it by pi r squared because they're asking me to find an area, and this is the area of a circle formula. So this is really just a plug-in problem, right? Really nothing tricky going on. So we're going to say 42 out of 360 times 20 is my radius, squared pi. Okay? So I'm going to simplify this. 20 squared is 400. Oops, let me put that in the right spot. Okay? So area equals, this is 400 pi, right? And then this, I'm going to try to simplify a little bit. So again, if you're trying to simplify these, you want to leave your answer in terms of pi, which means you don't want to divide 42 and 360. We want to reduce 42 over 360. All we're going to do is just try to find anything that's in common between 42 and 360. And so what I'm noticing, the kind of thing that's jumping out to me, is that they both definitely have a 6 in them, right? 42 times, or divided by 6 is 7, okay? And 360 divided by 6 is 60. And that's actually reduced completely. If you only notice that maybe they had a 3 in common or a 2 in common, that's fine as well. You just have to reduce in more steps, right? I have more simplifying I can do, though, because I'm noticing the 60 here, right? This is really over 1. 60 on the bottom and 40 on the top can be reduced as well. And so I believe that these have a 20 each in them, right? 20 and a 20. So I'm going to reduce this some more and say this is 7 over, when I divide 60 by 20, I get a 3. When I divide 40 by 20, I get a 2, right? So now this is actually going to be simplified. Multiply across the top, I get 14 pi, okay? And when I multiply across the bottom, I get a 3. So the area of this is in centimeters squared, 14 pi over 3 square centimeters, okay? Problem number 8. Okay, so we're saying, again, circle O has a circumference of 20 pi. So I'm going to pause right there and say circumference of 20 pi. So if I go to my circumference formula, okay, which is pi d, okay, if they told me that the circumference is 20 pi, okay, it looks like, just kind of comparing the left-hand side and the right-hand side, that d has to be equal to 20. Or you could just divide both sides by pi and find out that the diameter is 20. So we can answer the first question right here. What's the radius? Well, that's half of the diameter. It has to be 10, and I believe this is in inches. Yes, 10 inches, okay? So it's a very simple, straightforward first problem. I saw that they gave me a circumference, wrote down the circumference formula, and I worked my way backwards and found out that the radius is 10, okay? So it says that the central angle, measure of angle AOB, right, which is what's labeled in our picture here, is 60 degrees. So we found the radius of the circle, done, okay? Area of sector AOB, so again, that's just the area of sector formula, which is, in our problem, 60 out of 360 times pi r squared, which would be pi times 10 squared. And be careful, we're using the 10, not the 20. So I'm just going to do 10 squared, which is 100. All right, so again, we got to simplify going on here. This is really 1/6, okay, 1 over 6 times 100 pi. And I have a little bit more simplifying I can do. I can divide both of these by 2, okay, which I'll just kind of in our answer do. So this is going to be 50 on the top, okay, and a 3 on the bottom. So I'd say 50 pi over 3. This is an area, so I'm going to do this one in square inches, okay? And again, here's an area of a triangle problem. So area of triangle AOB, that's this one right here, okay? So it looks like they're giving me a triangle that has one vertex of 60. We know that the radius of the circle is 10. So OB is a radius. This is 10. OA is also a radius, so this is 10. Excuse me. So I'm going to draw, again, pull the triangle out, okay, and I'm going to actually do it on the bottom so I have a little bit more space. Okay, so here's my triangle. This is really what they told us. This is 60, and I have 10s surrounding it, okay, and our job is to find the area of this shape. Excuse me, again. So to find the area of a triangle, any triangle, we can just use 1/2 base height. Okay, so the base would be any of the sides. We're going to say it's the bottom one here. Okay, and the height is going to be at a 90-degree angle. Well, let's pause before we actually get into the height. Okay, taking a look at this picture, this is not just a regular old triangle. We know that it's definitely an isosceles triangle. So we know that because 2 of the sides are the same length. They're both worth 10. And so in isosceles triangles, if you go across from each of the equal angles, each of the equal sides, those angles are equal to each other. Okay? So what we know is that these 2 angles right here are the same length. So let me get rid of these arrows. Okay? So if these are the same length, they need to split whatever's left over in the triangle's total number of degrees, with the exception of that 60 at the top. So we know that triangles are worth 180 total when I add up all 3 angles. We've used up 60 of it, which means 120 left over, and that 120 needs to be equally split between these, which actually means 60 and 60. Okay? So not only do I have an isosceles triangle, I can say now more specifically I have an equilateral triangle because all of the sides all of the angles are 60, and that means that this bottom side, which is what I'm calling B, is also 10. So I'm going to plug that into my formula. 1/2, my base is 10. I still need to find my height, so we have to draw that in. So I'm going to draw in a height. Okay, that goes from the vertex to the opposite side, and it makes a right angle. Okay, so this is a right angle. So the 60 at the top got split into 30 and 30, and that is a property of isosceles triangles. Okay, and the 10 at the bottom, what we're calling the base, just for right now, I'm going to get rid of that, and I'm going to split that as well into 5 and 5s. Okay, and again, that's a property of an isosceles triangle. So I'm going to focus now on this right-hand 30, 60, 90. Okay, and again, I'm just going to clean up a little bit, make it look a little nicer. So it looks like the short leg of my 30, 60, 90 special right triangle is 5. And the rule for 30, 60, 90 says if you take the short leg and you multiply it by the square root of 3, you'll get the long leg, which the long leg is this height that I just drew in. So this has to be 5 root 3. Okay, so now I can multiply this out and say this is half of 10, which is 5. 5 times 5 is 25 root 3. And so that's what we're going to write for the area. So let's come back up top, okay, fill in the blank. Area of AOB is 25 root 3 inches squared. Okay, the area of the shaded region, okay, is the little segment, okay, this little red space here. Okay, so the area of that space is going to be the area of the sector, this entire thing. So let me draw what the sector looks like. The area of the sector goes from A to O to B, and then it is the arc that bounds those radius lines, right? So that right there is the area of the sector, which we found out is 50 pi root 3. Okay, so if I take that 50 pi over 3, and I said root 3, 50 pi over 3, and I subtract off this triangle, which we said is 25 root 3, okay, that will be the area of the little shaded space, right? The sector minus the triangle is what we call the area of the segment, which is the shaded region, okay? So the last piece here, this last question is what is the arc length of AB? Okay, this is unrelated to all of the other calculations that we do, so I'm just going to kind of try to squeeze it in here, and I'll use a different color, right? Arc length is, in this case, 60 over 360, and then pi d would be 20 pi, okay? So again, I'm going to do my simplifying. This is really 1/6, okay, times 20 pi, and then this simplifies to 10 on top and 3 on bottom when I divide by 2's, and that's my answer, 10 pi over 3. A length is going to be just in regular old inches, not in square inches, okay? So again, pretty involved problem there. A lot of questions that they asked of us, but we are capable of those, okay? Problem number 9, area of the shaded region. Okay, again, shaded region problems are going to be basically find the area of the big shape, subtract off the area of the white space. What's left over is the shaded region. So it looks like my big whole shape is a triangle. So I'm going to start off with finding the area of the triangle, which is 1/2 base height. Okay, and in my problem, the base is 12, and my height is also 12. From K down to M is the height. Okay, so that looks like half of 12 times 12, or half of 144, which is 72. Okay, so the area of the triangle is 72 centimeters squared. Okay, parallelogram, which is the area that I'd like to remove from this 72, the area of a parallelogram, which I'll put underneath the parallelogram, is just base times height. Okay, so my base for this one is the 6, right? So I'm going to say area of 6, and the height is going to be this little 3 here. Okay, so 6 times 3 is 18 centimeters squared. Right, so the area of the shaded region is just going to be 72 minus 18, which leaves me with 54 centimeters squared. Okay, so shaded region problems, area of the big shape minus the area of what you'd like to remove. Okay, last problem. What is the area of this irregular shape? Okay, so when we said whenever you get irregular shapes that you are not given formulas for, a good strategy would be to break it up into shapes that you do have formulas for. And so the way that you do this might be different than the way that I'm choosing to do it. As long as you can get the area of those pieces, that's fine. What I'm going to do is I'm going to draw on that line there, which creates a little rectangle. And if you notice, this is a 1/3 rectangle. So to find the area of rectangle is just length times width. This is 3 times 1. That little space right there is 3 times 1. Okay. I'm going to draw another line here, which turns this kind of weird L-shaped thing into two rectangles. And so now I got to figure out how to do this. All right, so the bottom one, again, pretty straightforward. This is 2. This is 2.5. If I do 2 times 2.5, this becomes 5. Okay, and so now I got to figure out what are the dimensions of this rectangle here, because they're telling us this whole long line is 3.4. But what we know is that this little piece, right, is part of this rectangle. This is 2, which means this piece right here, the rest of the 3.4, has to be 1.4. And remember, this is all of these shapes are not drawn to scale, and what that means is that when I look at this is saying 2 and this is saying 1.4, but in my picture, it's pretty obvious that this length is longer. So I wouldn't look at that and say, hold on, I'm doing something wrong because the longer line has the smaller measure. That's what we mean by not drawn to scale. Don't look at the picture and say it looks longer, so it should be a bigger number. Not necessarily true. Okay, so this one is going to be 1.4 times 5.5. So I'm going to say, let me bring up my calculator. I lost it. So 5.5 times 1.4, okay, means that top rectangle is 7.7 square centimeters. Okay, so if I add up 5 plus 3 plus 7.7, okay, it looks like I'm going to get 8 plus 7.7, which is 15.7 centimeters squared. And we are at the end of our review.